All right, so in this example, we're going to determine whether or not the series uh, n equals 1 to infinity of e to the n over n squared converges or diverges. Okay, so first off, this is not a geometric series or a p-series. If it was just e to the n, that would be a geometric series. If it was just the n squared, it would be a p-series. Uh, but notice we have a mix of exponentials and polynomials. So when we have something like this, we want to use the ratio test. Okay. So what ratio test tells us is we want to take the limit as n goes to infinity, take the absolute value of the n plus first term, so that's e to the n plus 1 over n plus 1 squared, all over e to the n divided by n squared. Okay, so everything in here is positive, so we can drop the absolute value bars. And dividing by e to the n over n squared is the same as multiplying by the reciprocal. So this is limit n goes to infinity of e to the n plus 1 all over n plus 1 squared times n squared over e to the n. Okay, so part of the reason why we want to use ratio tests in this example is we have an e to the n in the numerator and denominator. We can cancel that out. After doing that, we're left with limit as n goes to infinity of uh, e times n squared over n plus 1 squared. Okay, now if we look at this limit, if we take the limit as n goes to infinity, you can factor out the e, and then we end up with infinity over infinity, so we can use L'Hopital's rule a couple times, or you can factor out an n squared from the numerator and denominator. And regardless, we're going to end up with our limit being e, because this limit goes to 1. Okay, and e is 2.7 and change, so this is going to be strictly bigger than 1. And because that's strictly bigger than 1, that tells us that series diverges by the ratio test. Thank you.